In this video, we'll see how to debug our code to detect possible errors. This debugging is carried out by introducing breakpoints, which create a pause at a specific place in the code, allowing us to see the values of the variables at that moment and why it might be failing. This time we will use a library called pdb, and in the following video, I'll show you how you can install a kernel called Python. This kernel contains a graphical interface that allows us to carry out debugging in a much simpler way and is very similar to those used in other development environments, such as PyCharm, Eclipse, and NetBeans. These are some of the commands we can use when debugging our code with the pdb library. In this example, there's a function called multoperation, which receives two parameters, num1 and num2. Inside the function, we perform multiplication using the variables num1 and num2. The value of num1 is generated with this first loop, and the value of num2 with this other for loop. This num2 variable will take the value of y as long as it is less than or equal to 2. If this condition is not met, the value of num2 will be calculated by dividing the value of x by the value of y. We only consider the integer part and multiplying it by 10. We call the multoperation function, within which I'll ask it to not only multiply the variables it receives, but also display the result on the screen. I'm gonna run this code. And we see that in some of the multiplications, it gives us a value equal to 0, which is incorrect. To see what is going on, let's import the pdb library and insert a breakpoint before calling the function to see what values the variables we are sending as arguments have. To do this, we add the setTrace function belonging to pdb. Another thing I'm going to do is make the line numbers visible, going to the View menu and clicking on Show Line Numbers. Before starting debugging the code, I'm going to reset the kernel and clear all outputs, which we do in the kernel menu. This is very important because the variables could contain the values obtained in previous runs, which would contribute to an incorrect interpretation of what our code is doing. Let's now start debugging. I'm going to run this code. And we see that it displays a cursor and a little box for us to input the command we want to use. Above this box, it shows us the line number it is currently on, in this case, line 27. Which is the one that comes after the breakpoint. The cursor is located here, but it hasn't executed that line yet. What it did execute are the first cycles of the for loops and the if statement. So if I ask it to print the values contained in number 1 and number 2, it will do so. So we place a p followed by the name of each of the variables. To move forward with the code, we use the end command, which corresponds to next. And we see that it prints the result of the multiplication, which means that it not only called the multoperation function, but also executed it. If we see which line it is on right now, we see that it took us to the second for loop, meaning it will increment the value of y, which is correct, as the inner for loop finishes executing first and then the outer one. Here we can do two things. Press next to go through line by line, or press it to continue to get to the next breakpoint. I'm going to press the C key. We're back at the line where we call the function. Now, instead of moving with next, I'm going to indicate that I want it to move forward with the step command. This command will allow us to enter the multoperations function, so we can go through it line by line. I'm going to press next. And next again. Now that we're on the line where we print on the screen, I'm going to use the step command, which takes us inside the function, so you can see what it does. It goes to the iostream.py script at line 610. That is, to print to the screen, the first thing it does is go to this script. If I continue with the next command, it will take me through all the scripts it uses for this task. But since we're not interested in knowing what it does to print to the screen, what I am going to do is use the continue command, which, as I mentioned, will take us to where the breakpoint is. I'm going to ask it to print the value of the variable num2 again. And we see that it gives us a value equal to 0, which means the error is around here. Let's see what value y has. It has a value of 3. It means that the instruction in the else part of the if statement is incorrect. If we see the code, it divides x by y, gets the integer, and then multiplies it by 10, which means that whenever x is less than y, num2 will have a value of 0, and that's not what we want. What we want is to divide x by y, multiply it by 10, and then get the integer part of the result. I'm going to move it to the end of the line. Now that I've corrected the code, I'm going to exit the debugger using the Q key. Restart the kernel and clear all outputs, and run the code again. So as not to rerun the debugger commands, I'm going to comment out the line where the breakpoint is and run the entire code. And now, none of the results are equal to 0 anymore.